Let's make a cyberpunk mobile racing game. Admittedly, we haven't done a lot with mobile games, so here's our chance to fix that. To start, you need to create a new project. Pick a name, choose where to save it, and then pick mobile landscape and desktop as the resolution preset. Don't optimize for pixel art, and if you want to add a leaderboard, you can leave allow players to authenticate in-game ticked. Now all of the objects here are from the Cyberpunk Neon World and Cyberpunk Neon World Race Edition asset packs. Now these are both paid asset packs, but if you don't feel like buying those, you can still follow along and use another car pack to build this game. So to begin with, this background is a series of tiled sprites all put into a group called road pieces. And then at the end of the road, there are 4 objects I'm calling car spawners. And that's where the cars are going to spawn to that'll be obstacles on the road. And then we have the player character, who is the red car. And then the purple car object are going to be the obstacles on the road. Then we have up and down buttons to use as the controls on screen, and those are both done with the new custom button object. And then lastly, there's 2 text objects to show the speed the character's going at and the distance they've gone without blowing up. Now for the player object, I've installed the smooth camera extension, and then applied it as a behavior to the object. I've changed some of the settings, so the camera follows much more quickly, and it only follows along in the x-axis. Then I changed the camera offset along the x-axis by 420, so the camera is always ahead of the car. And then lastly, I added the tween behavior to the car. And the car has an object variable called car speed that we'll be using to control the character's speed. So that was the setup. Now let's go to the events. Let's start with the car's movement. The car object came with a series of animations for going up and down, getting hit, dying, and then driving forward. So for the car's movement, if its animation is not death, then we'll be able to use the controls. So if the animation is not death, the first thing we do is add an instant force to the car based on that object variable. And that's how the car is going to move forward. Because if we look up, there's an event where at the beginning of scene, we tween that car speed variable to 1,000 over 10,000 milliseconds, which is just 10 seconds. So that's how the car starts at 0 and builds up to 1,000. It's being moved based on that variable. Then, if the tween move of the red car is not playing, set the animation to horizontal right. So if you're not going up or down, you're just going to the right. But then if you do want to go up and down, we have the conditions to check if the up or down button is pressed, whether the move tween is playing, and then whether or not they're within the bounds of the road, which in this case is 97 to 481. But for your game it's going to be different, so you'll need to measure. So if those conditions are true, then we're able to control the car. If we press the up button, then we tween the Y position of the car from the car's original position to that position minus 128, which is the size of the lanes in this game, which again will be different for your game, so you'll have to measure. And it does that over the course of 400 milliseconds. Then it changes the animation to the one that tilts up and plays a drifting sound. And then if we press down, we just do the opposite, where we tween to 128 below the car and change the animation to the one that's tilting down. So now there's a car that's moving forward and can move up and down on the road. But the car would leave the road behind if not for the above event, where we change the X position of the group road pieces to be equal to the red car's X position minus 2 widths of the red car. And then we change the X offset of the group road pieces to equal the red car's X position times 2, which means the road and buildings will scroll 2 times faster than the car is actually moving. And that's to give the illusion of speed without having our objects move really quickly. And then the car spawner objects have their X position changed to the roadside top bounding box right, which means they're going to be placed at the far right side of that road tiled sprite. And then lastly is to change the Z order of the red car to equal its Y position. So as you're going up and down the lanes, you'll be ahead or behind the other cars on the road based on how high you are in the scene. So if you turn down and collide with one, you'll be behind them, and that just helps with the illusion of depth. And now if we scroll down, to the car spawning events, we have at the beginning of scene, start the car spawning timer. And then in the next event, we pick a random car spawner, and then when the timer gets over this equation, which is just 600 divided by the speed of the car, so when you get to top speed, you're spawning one car every 0.6 seconds, because it's 600 divided by 1000. And I'm using that equation because that way, when you're building up speed at the beginning of the game, you don't have a bunch of cars spawning in front of you. And they only start to spawn quickly once you get to full speed. So once that time is triggered, we create a purple car at the X and Y position of the car spawner that was picked randomly, and then change its Z order to be equal to its Y position, and then add a permanent force to the car between 100 and 500. And this will help give some variation to the game, so every car isn't just moving at the same speed. You've also got to watch out for the ones that are going fast and slow that might box you in while you're driving. And then lastly, we reset that timer so the event can trigger again in 0.6 seconds. And this next event is just for clearing up the cars that fall behind you. So if a car gets to be less than the X position of the road, minus 200 to give you some buffer, we delete that car. And that's just so that we're not worried about hundreds of cars lowering your game's performance. So if I zoom out the camera, you're going to see exactly what's happening. The entire level is moving forward, with cars being spawned in front, you dodging them, and then they get deleted behind. And the level looks like it's stationary, but it's being kept in place by the smooth camera behavior that we added to the red car. Without that behavior, the level would just drive off without us. And then the last thing we need to worry about are collisions. So the first event is when a purple car runs into another purple car. As long as the animation is not already death for that car, set the animation to death, play an explosion sound, and stop the forces applied to that car, so it will stop driving forward. And then, if the purple car's animation is death, and the animation finishes playing, then we delete the purple car. And then, if the red car that you're controlling hits a purple car, and the animation of the red car is not death, then we set the animation of the red car and purple car to death, change the variable car speed to 0, stop the forces on the purple car, and then stop the tweens, speed, and move. So if you die while you're moving, or while you are speeding up, you'll stop where you are. And then play the explosion sound. Then, if the red car's animation is death, and the animation is finished, use the action to wait 2 seconds, and then change the scene back to the one that we're on to restart the game. If you would like to learn more about the custom objects, like the custom button object in this game, then check out this video. Let's make a tower defense game. Now for this, I've built off of the city builder example, so I won't be explaining the things that were covered in that video, like selecting the building, placing it, and spending and earning gold. But let's look at the setup. I've got the indicator showing where the tower is going to be placed, the tower icon, which is the button in the top right corner, the tower base, and then the tower head, which will be the part that rotates to follow the enemy. Then the bullet that will be fired, the gold text to show you how much gold you have, the road that they'll be walking on, the zombie enemies that will be the actual enemies in the game, and then points for them to walk to, as well as a spawn point for them to start at, and a button made with the custom button object that's going to signal when the next wave should happen. And then there's a shape painter object that's used for the range, so you can see that circle around the tower before you place it. And then with the resource bar custom object, we have a life system. And now for behaviors, the tower head has the fire bullet extension, which you can find by adding new behaviors. The zombies have the health extension, as well as the tween behavior. The tween behavior will be there by default, but for the health one you'll need to search in the add new behavior tab. And then for variables, we're going to need to get into arrays, which were recently updated to make them a lot more user-friendly. So if we go to the zombie, go to its variables, there's an array for target X and target Y. And an array is just like a structure where you can have multiple variables like a folder inside of the structure, but with an array, everything comes out numbered instead of having a name, and you can add and remove numbers to the list. So those two variables in the zombie are going to be used to go to each point on the map. So we're going to fill up that array with the X and Y position of the first point, the second point, and then the third point, and use those points so the zombie knows where to go. And then in the scene variables, we have two more arrays. We have the wave array, which has our waves listed in it. So the first wave will have 5 enemies, the next one will have 10, the next 15, the next 20, the next 25. And the next array is being called Q. So the idea is that when we press the next wave button, what we're going to do is take this first variable in the wave array and add it as the first variable into the Q array, and then remove it from the wave array. And then we use the variables in the Q to tell the game how many zombies to spawn. So if when the game starts, I press next wave 3 times, it will move 5, 10, and 15 over to the Q, and then it will spawn 5, 10, and 15 zombies in a row. But then to actually do that, we need to go to the events. So to do that thing I just described, we have this first event. When the next wave button is clicked, add the variable wave0, which is the top number in the list, to the array variable Q, and then remove the variable at index 0 from the scene array variable wave. So we move the variable to a new list, and then remove it from the wave, which will move everything else in the list up. Then for spawning, at the beginning of scene, start the spawning timer, and then when the timer is above 1, and the number of children in the array variable Q is greater than 0, so as long as there's something there, and if the number of that scene variable Q0, which is the first one on the list, is greater than 0, reset the timer so you can do this again, create a zombie at the spawn point's X and Y position, and then change the scene variable Q0 by subtracting 1 from it. So we've created a zombie, and then we take 1 off of the number from the Q. And that on its own would spawn 5 zombies that would stand in place. But now to get them to move. So we set the variable count of the zombie object that we just created to 1. And then, repeating for each instance of point in the game scene, we check to see which point number of the point object is equal to that count. So if we go into the scene, you'll see each point has a variable called point number. And if we open up the properties panel, you can see I've changed that number in this panel by changing the first one to 1, the second one to 2, and the third one to 3. So the zombie starts with the variable set to 1, so this condition will pick the point object that has their variable set to 1, and then add that point's X position and Y position to the arrays in the zombie for the X position and Y position. Then it will change the count number to 2 because it adds 1 to it. And because this is repeating for each instance of point, and there's 3 instances, it will do this again, but this time for 2, because we changed the count variable to 2. So it will add the X and Y position of that second point object, then it will change it to 3, and it will pick the third point object, and do the same thing, add it to the lists. So now inside that zombie object are 2 lists of the X and Y positions of the points they need to go to. Then, tween the object's position to the first X position on the target X list. And to get this, it won't exist already, so you'll need to go to the expression builder, search for object variable, pick the zombie as the object, pick target X as the variable, but then add, in square brackets, 0, and then press apply. And you'll see it's zombie variable target X 0, and then do the same thing for Y. And then for the duration, you could put a set number here, but then the zombies would move at different speeds based on how far away the points are. So instead I'm using the distance between the 2 points times by 10. So this is the zombie's X and Y position compared to where they're going, which you can just copy and paste from up top. And then times that by 10 because milliseconds are really tiny. And now the enemies are spawning in a queue and moving to points. To find out about placing towers, shooting zombies, and losing your lives, you'll need to check out the next video. But first, if you want to check out the example that this was built off of, check out this video. Let's talk about tutorials. Every game needs one, and if you think that yours doesn't, you're wrong. Every game teaches their player how to play the game differently. You have Cuphead, which makes an entire different scene for the player to play around in. Or you have games like Mario that start off really simple, teaching you 1 or 2 mechanics at a time and then to add more and more layers as you go. But that's mostly game design stuff. Let me show you how to actually do that in GDevelop. So to begin with, I have this game here that I opened up. It's the Notavania example game. and I've added 3 tutorial blocks, just images on screen to tell the player which button to press. Importantly, the walk is first on this first platform, and then just after the jump key is shown, and then just before the first interaction with an enemy, the key prompt for attacking is there as well. So if I start the game, you'll see the A and D keys work, and then I'm told to jump. So now I know that the player knows how to do the jumping because they've gotten beyond this point. And then I'm told to attack. And I can do it here before the enemy gets to me in a pretty safe way. The enemy's pretty slow and not a big problem. And then I can continue on with the rest of the game because those are the only buttons. But this game has a tutorial in the menus section, so some players might have already learned the key presses before they start the game. So we're going to set it up so that each of these prompts only shows up when they're actually needed. So make a group called tutorial, and then go back to the events and add an action for hiding the tutorial group. We'll also start a timer called move tutorial. Make a scene timer, and then we'll check the scene timer. Move tutorial is greater than, let's say, 2 seconds. And if it is, show tutorial for run. There we go. And we will also set up a scene variable that is going to block off how that works. So we'll go structure, move, tutorial, Boolean true, oh, no, Boolean false, and apply. Okay. And we'll set it up so that when the Boolean variable for this is false, and we are standing there for 2 seconds, we'll show the timer. And then we'll change this. So if the player is moving, if the hero hitbox, which is the actual character, is moving, we'll set the scene variable for move back to true. And so the way this works out is once you start moving, this will be set to true, which will turn this off and cancel this out. Okay, let's change this to key pressed. A or D. Okay. There it is. Maybe make that longer. 5 seconds? So preview the game, and if the player stands there not sure what to press or what to do, it's going to pop up like that. And then the player will move, and because there's nothing telling them how to jump. And so we'll do the same thing, but we'll make another variable for jump. Boolean. That needs to be a global variable. Actually, I'm going to move all of those to be global variables instead. Global Boolean. So now we'll do the same thing basically. We'll copy this. Fall 1. If the player is in collision with fall 1, so they fall down this pit, we'll set this Boolean to true. And this time, if it is true, we will show the tutorial for jump. And we'll do this once. Okay, let's try that. So if I stand still for 5 seconds, and then if I walk forward and fall, Shoot. Let's make this beginning of scene only. There we go. Alright, so if I walk forward, it didn't happen, but when the game starts again, there we go. Now it's there. So now I know to jump. And we only need it in the first pit because once the player's gone past the first pit, you know that the player can jump. Otherwise, they wouldn't have been able to get over here. But I have 2 more examples here I want to show you. So the first one is the 3D tile builder game. So what I want to do is teach the player or tell the player to do these things without writing text up on screen or something. And a really useful tool for that is actually the extension Shockwave. All right. So I just need to create a shape painter object, call it Shockwave, add the behavior to it. All right. And then I will make a new group here for the tutorial. And I'll use a timer. Timer will be called tutorial start. And I'll create a shockwave object at the center point of the button every 0.5 seconds and restart the timer. So we'll start doing that. Nope. On the UI layer. There we go. 0.5 seconds is going to do that, and I can change the settings and make that bigger or smaller here in the behavior. But we'll just leave it the way it is for now. And so we'll do that when the game starts to tell you to do this. And the same way we used Boolean variables before, we'll do the same thing here. We'll use false. First house is false. So as long as the Boolean variable for first house is false, this timer is going to continue to reset and continue to create that shockwave object on the point. And then if the house is selected, we will set the Boolean variable for that to true. So when we buy our first house, click on the tooltip and then buy, it'll go away. And then we want to progressively tell the player to now do the next thing. So we'll do the same thing, but this time we'll create a new variable for the other 2 buildings. First stone, first wood. Okay, same thing. And so now we're going to change this so that if the condition is now true, so they've clicked on that and they've created their first house, now instead we'll be doing first stone and first wood and creating these at the position of the mine and the lumberyard. All right. So when I place this, it should start telling me to place those because we have 0 wood and 0 stone. So the next thing to do is place these to get stone and wood. But we need to again add in those points where once we buy that thing, we'll change the Boolean first stone and first wood. And now we know the player's first move is going to be to grab this and place it. And then the game's going to tell them to place one of these 2. Place it So they'll start gaining stone, and now they need to place the lumberyard. There we go. So now they'll know to place these 3 things, and they can start playing the game properly. You could also do showing and hiding bits of UI, so I could hide these instead of pinging them with the shockwave. And one last very quick one to do that I find useful myself is a pop-up for when you get in range of something. So this E right here is there all the time to tell you how to interact with this character. But instead, if we want to make it so that the E only shows up when you walk up to the character and you can actually press E to talk to them, we can do that. By going into the events, already it's set up to hide when you start talking with them, so we'll just change how that works. So instead, we're going to make it hide when we're within this range of them. Or sorry, we're going to make it show then and hide when we're not. So when we're not in range of the character to talk to them, it's going to hide it, and then it's going to show when we are in range of the character. This is using the distance between 2 objects. You can also use distance between 2 points expression, or some other way of telling that the player is within a certain range of the thing you want to interact with. So now when I walk up, it's not there, but when I get close, it pops up. That's something you'll see in lots of different games. It tells the player when and how to interact with something. Hopefully this video will help you start setting up your tutorials, but for now, check out this video. We're going to set up some custom key bindings. So to begin with, I have a platformer character with some animations, and they have the platformer behavior. Along with that, I have these 3 events set up, where when the button is clicked, it will remove the key binding from the variables we have set up. And those variables are these global variables here, under this structure called control. Key jump, key left, key right. And then the button we want to press as a string inside that variable. So if I preview the game, when I press on these keys, left, right, or spacebar, it will remove that variable from the list. Like that. Now, with that as the starting point, we're going to go to the platformer character, turn off the default controls, so you can no longer use the arrows and spacebar. Then we're going to add these controls here. So we're going to look for the condition key pressed, and we're going to use the text expression version of that condition. And in here, we're going to type in control for that variable, select that, and then we're going to start with the jump. And so when this variable control jump is pressed, then we're going to simulate a jump. There. Now, if I preview the game, I can press space to jump, because this is space, and when I remove it, I can no longer jump. So now we'll do the same thing for the other 2 key presses, and we'll use left and right, and we'll change these to simulate pressing left for the player, and simulate pressing right for the player. So now I can use the A and D keys to move back and forth, because these here are linked up to the character. And then when I remove them, I can no longer go in that direction, because now this is just blank. So now to put something back in after we've removed the variable. So with the condition any key pressed, we're going to check if a variable has something inside of it. So we'll go global variable, text, because all of this is being done with strings or text. And we'll start with jump again, and then we'll put in 2 quotations for blank. So if this variable for jump key is blank, then we can copy this for the jump key, remove the quotations, and open the expression builder. We can look for last key pressed. There's the expression for last key pressed. So now, when I press any key, it will check if the global variable for key jump is blank, and if it is, replace it with whatever I pressed. So let's try that out. If I preview the game, remove the spacebar, so it's gone, and then I'll press C. There it is. And now I'll jump. So now I can use D and A to move back and forth, and C to jump. And then I'll do the same thing with the other two key bindings. One for left, and one for right. So now I have default key bindings based on what's already in the global variable structure. And when I remove them, I can replace left now by pressing J. And then I can replace right by pressing Y. And suddenly my key bindings are Y and J to go back and forth. Now with this setup, if you have all of them removed, that would happen. So instead, you can do a couple of different things. And the easiest way to do it is probably to make it so that if these are blank, then the buttons won't work. And so to do that, we'll just put these as a sub-event and copy these three conditions. And now with all three of these conditions here, I can change this to not equal to. And now as long as none of the variables are blank, they'll work. But if one of them is blank, then that no longer works. So only one of these will be blank at any given time. And so now when I press the key, it will replace it, and I'm able to remove another one again. And now in case you have any trouble with that system and need to fix it, check out this video. I'm going to go over 3D first-person movement in GDevelop. So to begin with, there is a premium game template for 3D first-person movement with a gun. So a first-person shooter template that you can buy in-engine right now. But there's also a free template called 3D first person that shows the basics of 3D first person movement. So I'm going to be going through that template and explaining how everything works. I'm going to be using the built-in 3D features in GDevelop, so the camera and player character are both a 3D box. And the extensions that you'll need for this example are Walk 3D, Jump 3D, First Person Camera, and Mouse Pointer Lock. And you can get all of those by searching through the extension list. And for two of them, notably Jump 3D and Walk 3D, you can get them by searching in the behavior list. So the first thing we need to do is get those extensions into the engine, and then add these two behaviors to the 3D box that in this example we're calling camera, where Jump 3D is the ability to jump, and Walk 3D is the ability to walk. So right now I have nothing set up, so if I preview the game, we'll just be looking at the scene from top down. There's the camera object. And so the first thing we're going to do is set up the mouse pointer lock. So if this is not a mobile device, and you left click, which means you've clicked on the screen, and you're not currently locked in with the mouse pointer, then we're going to request a mouse pointer lock, which will lock and hide your mouse pointer. Now, if your mouse pointer is locked, so after you've done this, we're going to rotate the cube along with your mouse movement. So the first thing we're going to do is change the angle, which is left and right, and we'll use the expression builder to get this expression. So we're looking for pointer X movement, because it's left and right, so it's the X axis. And then to slow it down to make it more manageable, we'll divide that by 20. So if I preview the game now, there's the cube, and if I click in, I can move back and forth with the mouse. Now the next thing is to change the Y axis. And again, we'll use the expression builder to find this. And we'll get pointer Y movement, and we'll again divide that by 20 to slow it down. To make it fully rotate, these need to be set to add. And now you can see the box is moving around freely. The next thing to do is make it so that we're no longer looking from top down, but through the actual eyes of the 3D box. So we'll use the action look through object eyes, and pick the camera object on the base layer. And now when I preview the game, we're actually looking around in 3D, but we're at the floor. So we need to change the camera's Z position and add the depth of the camera object. And now we're at the depth of the 3D camera object, because you can see the top of the box is actually quite a bit higher than the bottom. Next, we need to fix this problem, where I can literally turn the entire camera upside down. And to do that, we're going to change the rotation of the y-axis of the 3D camera object, and this time we're going to set it to a value where we clamp the camera object's rotation in the y to be between -90 and +90. So now the camera stops once I get to the bottom or the top. So now that we've got the camera working and looking around through the 3D box, we should get the character moving. Down here I've got it set up so we're using WASD and space for jump. So all we need to do is use the simulate actions for forward, backwards, left, and right. And this works by adjusting the direction the force is being applied based on the direction your camera's looking. So if I preview the game now, we can look around, and if I press W, we'll move forward, and S to move back. And it's all dependent on which direction I'm looking, just like a regular FPS. So now we've got the camera going and player movement set up. These are done with the walk 3D behavior that's set up inside the 3D box. So if I want to change how that works, I can change the values in here. The next thing is the 3D jumping. And to do that, I just need to add simulate jump as the action for the space key being pressed. And now if I preview the game and press space, the character jumps. However, to prevent going through all these objects and actually jumping on top of things, I need to add one more action. I need to add the action to separate from platforms. And the platform in this case is the barrier. So now I can jump up on top of these, and I won't go through them anymore. Now, I know a lot of people using the engine are making mobile games, so let's set up some mobile controls. The first thing to do is add these joysticks into your game. This one being set to number 2, and this one being set to number 1. So this is your left and right joystick, or walk and look joystick. So something that's set up in this example already is if this is not a mobile device, the walk and look joysticks are deleted. So if I disable that and preview the game, they'll be on screen. So to move the camera with the joystick, we're using the condition if the joystick is pressed, and then for the action we'll be using the simulate stick control rotation for the 3D walk behavior, select the camera, and then use the stick's force. Look joystick, force, in the X direction. And that will change the camera's rotation along the X axis. Then, we'll change the camera's rotation on the Y axis and add the look stick's stick force along the Y axis times 120 times time delta. And so if you want to speed this up or slow this down, you can change this value. So now if you preview the game, I can control the camera with the joystick. And now for player movement, we have if the walk joystick is pressed, simulate stick control, not for rotation, but just for control, for the camera. And we'll use the walk joystick's stick angle, and for the force, we'll use the walk joystick's force. Not in the X or Y direction, just the distance that the joystick is away from the center, regardless of which direction it's pointing. And now, I can control the walking direction with this joystick. That's how you set up 3D first-person movement in GDevelop. But for now, check out this video. Let's go over some effects that you might want to use in your game. So to begin with, I have an object with the platform behavior installed on it, and a second object with a bunch of animations and animation names as well as the fire bullet behavior. This sprite object that's just a box is going to act as the actual player, and then the second object is going to be the image of the player. And this way we're able to use tweens and effects and different sorts of things to make the character more interesting without affecting the collision mask of the player. Right now the character is pretty stiff. There's animations attached to moving around, and it can fire a bullet, but there's a lot more that we can do with the character. We do have a video on game juice or game feel, but in that video we show why it's important and not so much how to do it. In this video we'll be covering a bunch of different ways to add these effects and juice to your game. So to start with, we'll start with a particle effect. So we'll add the particle emitter object, and we could pick one of these nice fancy particle effects that are pre-made, but what we need isn't here. So I'm going to create a new particle effect, and then change the internal values and color so it'll make sense for what we're doing. We'll set the tank to 1 so it only creates one particle. Remove the emitter force, and then we'll go to the player image object and add a point for dust. Then in the event sheet, we'll add an event where if the player is moving and on the floor, we'll spawn that particle effect on the first frame of that running animation. So if the animation frame of the player character image is equal to 0, so the first frame of the animation, we'll create the dust particle effect at the point we just created. You need to add quotations, and then select dust. And then do the same thing for the Y position. And now if we preview the game and walk around with the character, we'll be spawning the dust particle at its feet. But it's spawning per frame. So we'll add the trigger once condition. And we'll change the size of the particle. But if you want to have something that's animated and acts like a particle, you don't need to use the particle emitter. You can actually create a sprite object and just delete it when the animation's finished playing, and that way you can have an effect that also plays an animation. So if I import the muzzle flash image, then I can go to the event where I'm firing the bullet and spawn that image in when we fire the bullet. And in this case, I already have a point made called bullet spawn on the character, so I'll be using that for the position. And then I can just check if the animation of that effect is finished playing, and then delete it if it is. The direction needs to be changed. So we'll need to use the direction that the character is flipped as the condition for this effect. Because the muzzle flash's image is off-center, it's not going to flip properly. So, we'll add another point to the character image object, and use that as the point for spawning the muzzle flash. And we'll have to change the position of the origin to the center of the object. But then we need to change the point to the newly made muzzle flash point. And that's lasting in the scene as long as the animation timer is set. So if I set that for 5 seconds, it would last for 5 seconds before being deleted. Then there's the Paint Shaper tool, which has a ton of uses, and in this case I'm going to use it for a shockwave effect. So I can go to the behavior section of this new object and add draw shockwaves in ellipse. And now we'll add an event where if the bullet collides with an enemy object, we'll create that shockwave effect by creating the paint shaper object at the point of collision. And deleting the bullet. And with some tweaking of the values inside the shockwave behavior, it's a really quick way to get some effects into your game. Another useful set of tools for effects in your game are tweens. So I can add the behavior for tweens to my player object image, and then I'll use the tweens to add some squash and stretch to the character. So using the action tween the Y scale of the object from the center of the object to 0.8 when they first land on the floor, and then when that landing tween is finished, changing the scale back to 1 will make the character squash down when they land on the ground and then bounce back up. And you can complement this by doing the opposite for the X scale, making it expand out and then retracting the other way. And make sure to give tweens different names so they don't overlap each other. And now when the character lands, they land with a satisfying little bounce. And then the last really important effect to know is camera impulse, especially for a game with a gun or directional force. So we'll look up and install the extension for impulse, camera impulse. And then when the character fires the bullet, we'll use the action for impulse, and then set the values. And then for this kind of game, you want the impulse to be in the direction that you're actually shooting in. So we'll use this flipped event and have one set to go at 0 degrees and the other one to go at 180 for the other direction. You don't need to use every kind of effect in your game, but all of these little touches really add up to make the game look a lot more polished than it was to begin with. This is the second video in a series where we're making a Zelda-like game. Last time we covered animations and movement, now for the attack. So going back to that same event, where the hero is not carrying anything, we have a sub-event where if you're pressing the J key, it changes the state variable to attack. And then the two events below it both have that as a condition, where the text variable can't be attack, and so those two are skipped over. Which means we get down to the bottom now, where we've changed the state, and so we set the animation to equal the direction that you're already in, plus attack. But for attacking, you don't want to be able to move around while you're doing it. Typically in games like this, you stand still. So below everything is a deactivate controls event, where if the text of the variable state of the hero is attack or lift, and by the way, you get this or condition by just searching for or. But whether you're attacking or lifting, we use the d/activate a behavior action and set it to no, so it disables the behavior so the player can't move. And then at the top of the event sheet, there's an event for if the animation isn't attack or lift. The Legend of Zelda: Tears of the Kingdom just came out and broke all kinds of records. So I thought this would be a good time to talk about Zelda: A Link to the Past, and how you could make a game like that in GDevelop. The art you see here is from a premium asset pack in the GDevelop asset store, but you don't need the art to make this game. So use whatever art you have available, or pick up these packs. So the first thing you want to do with any top-down game in GDevelop is add the top-down behavior to the player object. So if we open up the hero, go to behaviors, and then go to add behavior, you'll see it right here. You just add that behavior, and then go over to behaviors, and turn off rotating object. And from that point, the character will be able to move using the arrow keys. But the next thing for this top-down style of game is Z-ordering. And for this, we want to go into our objects, start with the hero, and change its origin point to be at the base of the object. And then do the same thing for all of the other environment pieces that you want your character to be able to move around and interact with. Then you would open up the groups panel and add a new group. In this case, I've called the group environment, and I've added all of the objects that I want to affect. And then in the event sheet, I have this event where at the beginning of scene, we change the Z order of the environment group by setting it to the Y position of the environment group. So every object in that group will be sorted by their own Y position, which is now that origin point that's at the base. And then we do the same thing for the jar, but then we make an event with no condition and use that action for the hero, changing the hero's Z order based on its Y position. And the last thing we need to do is go in and change the collision masks. When an object is first created, the collision mask will take up the entire space of the image. So you change it to a custom collision mask and change the size to make it fit the base of the object, or what looks like the base of the object. And then do the same thing for the hero and anything else in the scene that you want the hero to be able to interact with. And then in the event sheet, in that event with no condition, we use the action separate objects to move the hero away from the environment group. So the environment group will stay put and the hero will be moved. And then as a sub-event is a condition that checks if the jar has been lifted. And if that is false, then move the hero away from the jar, just like it was an environment piece. And if I preview the game, you can see the characters walking around, being separated from objects, but to this point, the character would just be a flat image and not the animated character that you see on screen. So, how do we do the animations? Well, in the object, we have two variables for this, direction and state, and both of them are strings, which means text. And then if we go to properties, we'll see the animations. And the animations are all titled in a way that makes sense with those two variables before. One half is the direction and the other half is the state. And if I go down through here, you'll see all of them. Left idle, up idle, right idle, down item stand, left attack, up attack, right attack, and so on. So to begin with, there's this group of events that are choosing the direction. If the hero has the up key pressed or simulated, change the text of the variable direction of the hero to up. And then if down is pressed, change it to down. If left is pressed, change it to left. If right is pressed, change it to right. Okay, so those were the directions. Now let's talk about walking and idle. So in this event, the condition is whether the Boolean variable carrying object is false, which means that you're not carrying something. And if that variable is false, then we move on down to the other events. Starting with hero is moving, and the text variable state of the hero is not attack. So you're not attacking, but you are moving. In which case, the text variable state gets changed to walk. And then the next one down is if the hero isn't moving, and the text variable state of the hero isn't attack, so you're not moving and you're not attacking, then it's changed to idle. So we're just looking at whether you're walking or idle. And then we go down the sheet, and we'll see this event to play the results. And the condition is comparing two strings, so if the hero's animation name, so if the animation that's playing currently doesn't equal the direction plus the state, set the animation of hero to equal to the direction string plus the state string. So in this case, it's up, down, left, or right, plus walk or idle. And that's how this works. When I press down and the character moves, that state goes from the direction it was in to down, plus now the character's moving, so it changes to walk. So the animation that plays is down, walk. So that's how this is working. It's direction plus the state, and that's the animation that's being played. But for now, check out this video. This is the second video in a series where we're making a Zelda-like game. Last time we covered animation can't move. And then at the top of the event sheet, there's an event for if the animation isn't attack or lift, then we set that behavior back to active by setting it to yes. And then to come full circle, the event for changing the state back to idle has a condition where if the animation of hero ever finishes, it changes back to idle. And if we go to the hero object, you'll see that all the animations are set to loop except for the attack and lift animations, which aren't. And so those animations are the only ones that can finish. So they reset back to idle. So now when I press J, there we go. And now for picking up and throwing objects. If we go to the hero's points, we have a lift point, which is where the jar is getting lifted to, and where you're walking around with the jar. And then just like for animations, we have points for down, up, left, and right. And we have that animation for lift. And of course that Boolean variable for whether or not you're carrying an object. And now in the event sheet, under the choosing state section, we have an event where if the H key is pressed, trigger once, and then down here, we check to see if there's a point inside the jar object, and instead of using the name of a point, the game is using the text in the hero variable direction. So the point being used changes based on the direction you're facing. And when these conditions are true, we change the state of the hero to lift, sets the Boolean variable lifted of the jar, which just tells us which jar is being lifted, to true, and then set the Boolean variable of the character for whether or not they're carrying an object to true as well. So then we know they're carrying the object. And finally, we need to tween the jar. So we need to add the tween behavior to the jar. And to do that, you just go to add behavior and it's right there for tween. So we add the action, tween the position of jar to the hero's lift point for both the X and Y position, and set that to 500 milliseconds, which is half a second. And now because we've set the hero's Boolean variable for carrying an object to true, we're skipping that next event, which means that now we're working with the events below it. But these aren't going to trigger this time because of this condition, which is whether or not the tween lift of the jar has finished playing. So these don't trigger while the jar is being lifted. So now we're in the state lift, which means the state has changed, and the new name to change the animation to is the direction and lift. And so the top-down behavior gets deactivated while the jar is being lifted. And when the animation is no longer lift, we get the controls back. And so that happens here, because we are carrying an object, the tween lift has finished playing, and now, if the hero isn't moving, we change the state to item stand. And if the hero is moving, we change the state to item walk. And if the Boolean value of the variable lifted of the jar is true, which picks the jar that we're carrying, change that jar's Z order to the hero plus 1, and change the position to the X and Y of the lift point. So it's above our head and above us in Z order. So now just like walking before, whenever I'm not moving, it's changing to the direction plus idle or item stand. And whenever I am moving, it's changing to direction plus item walk. And those are the animations that are being picked. And so to make this work, you need to make sure that your animation names are all written properly. And the very last thing is throwing the jar, for which there might be an easier way to do it than how I did, but here we go. So when the H key is pressed, and both the jar's and hero's Boolean variables are true, to let us know that the hero is carrying something and the jar is being carried, we set the Boolean variable for the hero for carrying object to false, so you're not carrying anything anymore, and tween the position of the jar to the X position of the hero's point of the direction they're facing, minus the hero's X position. So if they're looking to the left, that's the point behind them, minus the X position of the point under their feet, which gives us the difference. So if we do that for the left, we get a negative, and if we do it for the right, we get a positive, which tells us which direction to throw the jar, either in the positive, the right, or the negative, the left. And then we add the hero's X position to know where to start the throw. And then we do the same thing for the Y position, but using the Y coordinates instead. The tween identifier for this one, I just wrote down throw, and the duration again was 500 milliseconds, which is half a second. And then at the end of the throw, I'm deleting the object. And you could create another event to change the animation when the throw finishes, but this worked out for the example. There are a bunch of other examples in GDevelop to teach you different mechanics that you might need to know, and I'll put some of those in the description, like the example that shows you camera movement from one room to another. But if you want to learn how to actually attack and do proper melee combat for your game, then check out this video. The Legend of Zelda: Tears of the Kingdom. Let's continue talking about how to make a tower defense game in GDevelop. This is part 2 of the video, and in the last video, we went over spawning zombies, setting up the game, and the basics for arrays. So now, you're spawning zombies based on the queue, and then as each one spawns, it checks to see where those points are, and then adds the X and Y position of those points to its own list, and then moves towards the first position. And then if that first variable inside of the queue is 0, then remove the variable at index 0 from the scene array. So we get rid of it, and allow the next number in the queue to move up, so then it can be checked. And now that we've got our first zombies moving, we use this event to keep them moving. So use the event type repeat for each instance, and set it to zombie, and then if that tween move that they started with finishes playing, remove the top X and Y position, because this means they've gotten there already. And then if the number of children in the array variable, target X or target Y, you could use either one, of the zombie is greater than 0, which means that there's something in the list, use that same action that we used before to move the zombie to that next position on their list. And also use the action to rotate the zombie towards that position, with a speed of 0 so it happens instantly. And you can just copy these positions and paste them into the X and Y for the rotation event. And with this part of the event, each zombie will move from 1 to 2 to 3. But once they get to 3, we need to do something different. So if the number of children in the array for target X or target Y of the zombie is equal to 0, which means we've reached the third spot and there's nothing left in the list, change the value of the flat heart bar, which is the custom resource bar object that we put in, by subtracting 1 from it and deleting that zombie. So this means that they've gotten to the end and they've taken one of our lives. And if that happens to be the last life that they've taken, so the value of the health bar is equal to 0, change the scene back to game scene to restart the game. And then for the towers, we place the towers using the method that we showed in the other video that I'll link at the end, only in this case, we'll be placing the base and then the target head on top. And then this event is used to target and fire at the zombies. So repeat for each instance of tower head, and then use the condition if the tower head distance to zombie is below 200, rotate the tower head towards the zombie X and Y position at the speed of 0, and then use the fire bullet action from the fire bullet extension that I mentioned earlier to fire a bullet from the tower head to the zombie at a speed of 500. And to make sure that they're always shooting at the zombie, I added a point called shot point to the front of the zombie and used that as the position to fire the bullet towards. And then this action up here will kill the zombies. So repeat for each instance of bullet, check to see if the bullet's X and Y position is inside of a zombie, and if it is, delete the bullet and apply 1 point of damage to the zombie using this action that comes from the health extension behavior that I mentioned earlier. And then, if the bullet hits a zombie, and then the zombie is dead, so its health is 0, delete the zombie and give yourself 2 gold. Now I understand that was a lot to take in, but this last bit is easy. So I have a shape painter object that I'm calling range. I created it, changed its name, picked the colors, unticked draw the shape relative to the object's position on scene, and then in the events, whenever the indicator object is visible, use the draw circle action and the X and Y coordinates of that indicator object, and set the radius of the circle to 200, because that's the distance that we're using in the targeting event for the tower. Now in game, when the indicator is visible, the shape painter object will show a circle with a range of 200 pixels around the indicator. Although you do need to make sure that the shape painter object is placed into the scene so that it actually exists in game. And that is one way to make a tower defense game in GDevelop. Now, of course, if you haven't seen part 1 of this video, go watch that. Then maybe check out this video that should help you get more people to play your game.